So if you're still with me here, you were just doing 4.4, you were doing some inverses. Great, right? All right, but what's the point, right? Who cares? Well, now we're going to go over what the point is in 4.5. Why learn inverses? Well, you can solve systems using inverses. So here's what we're going to do. I'm going to teach you how to set this problem up. But before I do that, a little side work here for you. And here's the first side work. Um, when you're doing some problems, right? Um, let's say I gave you a problem like this and said solve it. Well, it's multiplication, right? So you divide both sides by 3. All right, no problem. Here's what else you could do. Instead of dividing, don't you agree you could multiply both sides by the reciprocal? Well, another word for the reciprocal is the inverse. And the reason why it works is because that crosses out 9 times a third, right? Will still give you the same answer. This is like the inverse, right? 3 to the negative 1 is like saying 1 over 3. They're the same thing. So the whole reason behind this is, what we're trying to say is, if you take the first matrix, which, here's what we're going to do. We're going to call the first matrix A. So the first matrix is 3, negative 2, negative 1, and 1. So if I take matrix A, here's a matrix, x, y. And here's why it works. Row by column, 3x minus 2y, negative x plus y, so it works, equals your answers. And this matrix we'll call matrix B. Okay. It's like saying this times this. Well, you can't divide. Dividing is the same as multiplying by the reciprocal or multiplying by the inverse. The point is, if we took a to the negative 1 and we multiplied it by b, we'll get our answer. And yes, it needs to be in that order because look, a is a 2 by 2 and this is a 2 by 1. The a has to come first so that you can multiply them together. So my point is, you need to do a to the negative 1 times b. So on your calculator, go to second x sub 1 again. So second x sub 1 and go over to edit and let's make a 2 by 2. And let's make it 3, negative 2, negative 1, 1. So we have a. Press second x to negative 1 again, go to edit, and let's do b. And b, we're going to make a 2 by 1, because it's 2 rows and 1 column. First number is a negative 1, second one is a 0. And press second mode. Here's what we're going to do. Literally, here's what I want you to type in. Go to second x to negative 1, and press enter on a. So this is what will pop up on your screen right now. This is what you should have. Press x to the negative 1, so you get a negative 1 there. Then press this again, but go down to B, and B should be right beside it. If you type that in on your calculator, it will give you your answer for x and y. And notice how it gave you something that looks like this. Negative 1, negative 1, because that's your answer. X is negative 1, y, negative 1. There's your answer. That's how simple it is. You can solve all systems by doing it this way. So, basically, 1, 2, 1, 1. That's A. So take the inverse of A and multiply it by B. B is negative 4, negative 3. Multiply the inverse of A times B and you have your answer. So let's just change our matrix around. So edit A. So it's a 2 by 2, but now it's a 1, 2, 1, 1. Edit your B and make that negative 4, negative 3. Oops, sorry, let's clear out of there. I don't know what I did there. Go back into your matrix. Let's edit B. We're going to make that a 2 by 1, and that is a negative 4, negative 3. And I end up getting for my answer negative 2, negative 1 when I type it in. Once again, remember it should look like this. A with a negative 1 and a B right afterwards, meaning x equals that, y equals that. All right, good. Let's move on to a 3 by 3. It works the same. Okay, and this method is surprisingly even easier than doing the determinants to find all the answers. Because what's your A? Your A is 2, 4, negative 2. 1, 2, 3, 4, 3, negative 1. Here is your A. So you need to find the inverse of it. Then your B. Your B is negative 8, 12, 11. So find out what your B is and multiply them together. So go to second, x to the negative 1, and let's edit. I'm going to make a 3 by 3 now. So it's 2, enter, 4, enter, negative 2, enter, 1, enter, 2, enter, 3, enter, 4, enter, 3, enter, negative 1, enter. Go back into your matrix again and let's make B. Now that is a 3 by 1, and that's negative 8, 12, 11. Go to second mode so you're out of it, and type it in once again. You want your answer to look, or you want the problem to show up like this. That's how you know you're plugging it in the right way in your calculator. And when you do that, I end up getting this: 6, negative 3, 4. That means that's x, that's y, and that's z. You know how long it would take you to do a linear combination method to solve this? Do you know how long it would take you to graph all three of these and find your answer where they all intersect? Do you know how long it'll take you to even do determinants to find this? Using inverses is so much easier in solving these problems. Believe me, it is so much easier. Let me give you one more here so you can see how it works. One last time. 6, 4, 3, 3, negative 2, 2, 2, 3, 2. That is your A. Your B is 6, 16, negative 1. That's B. So let's plug those in. So second, x to the negative 1. Let's edit A. It's a 3 by 3, but let's do 6, 4, 3, 3, negative 2, 2, 2, 3, 2. Then let's edit our B now as well. That's a 3 by 1. So that's a 6, 16, and a negative 1. So we go second mode, and I end up getting for my answer, remember, if you typed it in like this, you typed it in correctly. I mean, you typed it in correctly, not as in it's wrong. You end up getting 2, negative 3, 2. That's x, that's y, and that's z. So easy, a caveman could do it. So if you have any other questions or concerns, please let me know, and we shall talk later.